Now class, we go to this example 2. We want to find the volume that is generated by revolving the portion of the curve y equal to 2 over 3x between x 0 and 3 about x axis. So now it is revolved about x. What we need to do here, we have this function y equal to 2 over 3x. So if I plot this function, it is just a straight line that is a straight line with positive slope. Okay, this is our y equal to 2 over 3x. So class, this volume, we need to compute it between x 0 up to 3. Let's say here is 3. Means that the area of the shape is given by this area. So if this area is revolved about x-axis, means that it will revolve about x-axis. So we will have this kind of circle here. Connect all these, it becomes cone. We will have finally the region that we need to compute volume is given by all these region, and we denote this one as R. So how to compute this volume? B equal to the formula of integration starting from A to B pi. Remember, now it's revolved according to x-axis, means that our function should be function of x to the power of 2 dx. In this case, our fx is given by 2 over 3x. And our a here is 0, this is a, and this one is b. So here we'll have integration starting from 0 to 3 pi, which is times 2 over 3x squared dx. When we solve this one, we'll got here 4 over 9 pi. We integrate 0 to 3, x to the power of 2 dx. That is 4 over 9 pi, which is here x to the power of 3 over 3, 0 to 3. When we solve this one, we'll got here the answer 4 pi unit cube. Actually, class, when we want to compute the volume, your final answer, you can just leave in terms of pi. Now we go to this example 3. The question asks us to find the volume of the solid generated by revolving the region between y-axis and the curve y equal to 3 over x, where y here in between 1 and 6. So what we need to do for this case, for this one we have here y equal to 3 over x, our c equal to 1, our d equal to 6, and we want to revolve our shape according to y axis. Means that for this one, you have to use formula volume equal to the integration of c to d pi, and in this bracket should be f y to the power of 2. You integrate respect to y because we revolve according to y axis. So now we have this function that is y equal to 3 over x. How can I get fy? Fy here means that you have to make x as a subject. That is, we will have here x equal to 3 over y. Actually, when you plot this function, we'll have got this kind of shape. So when we revolve it according to y-axis, means that you'll got here this kind, this one, and finally you'll got this kind of shape that is has a form of this shape. And here, for example, we want to compute the area for y between 1 to 6. So for example, this one is 1 and here is 6. We want to find this volume. Okay, means that this is our region R. So that here we have the integration starting from 1 to 6. Remember, the coordinate on y-axis, no longer x-axis, because we integrate respect to y. Pi, and our function now, it is in terms of y. So we have here 3 over y square dy, which is, we'll got here the answer, the integration 1 to 6 pi which is here 9y to the power of negative 2 dy. That is equal to 9 pi. We integrate from 1 to 6y to the power of negative 2 dy. That is, we'll got here y to the power of negative 1 divided by negative 1, which is 1 to 6. That is negative 9 pi. We have here 1 over 6 minus 1. So when we solve this one is negative 9 pi times negative 5 over 6, which is the answer is 45 pi over 6. This is the volume for this example 3. What I did here, first we need to write our function in terms of y, and then we substitute here, and you have to substitute the limit which is given in the equation 1 to 6 here. Then you integrate this function, and then you will got a final answer, actually 45 over 6. It is equal to 15 over 2 pi. So class, it comes to the end of week 14 part 3B video, which is this is the last video of your online learning. I hope everybody still can understand what you have learned before this, and if you have any problem, please feel free to contact me. So thank you class, see you in your final exam.